this is a review of the topics that I've covered this week. We've got standard form, compound interest and depreciation, percentage change, and reverse percentages. So let's start with standard form. So the examples, right, in standard form, we've got 380,000. So standard form is a number between 1 and 10, which is going to be 3.8 in this case, then multiplied by 10 to a certain power, a certain number of times. So how many times do we multiply 3.8 by 10 to get 380,000? So 1, 2, 3, 4, 5. 3.8 times 10 5 times is the same as 380,000. The second one, we've got 0.00541. Again, a number between 1 and 10. In this case, we're going to take 5.41 multiplied by 10. How many times? Well, we actually want to divide by 10. We want to divide 5.41 by 10 a certain number of times to get 0.00541. So it's going to be a negative power. And having a negative power of 10 is the same as dividing by 10. So how many times do we divide 5.41 by 10? So it's going to be 1, 2, 3 times. Or the trick is to count the number of zeros, including the one before the decimal place, and that would be 3. That only works for negative powers, not positive powers. Okay, write as ordinary numbers. So the other way round, we've got two numbers in standard form, and we're going to write them as ordinary numbers. So 3.2 times 10 to the power of 4 means 3.2 times 10 4 times. So times 10 once to make 32, then 2, 3, 4 times. So 3.2 times 10 to the power of 4 is 32,000. 9.6 times 10 to the power of negative 6. So 9.6 divided by 10 6 times. So we're going to have 1, 2, 3, 4, 5, 6 zeros, and then a 9, 6. So 1, 2, 3, 4, 5, 6. So if we start with 9.6, divide by 10 once, 0.96, twice, 0.096, 3, 4, 5, 6 times. Okay, some questions for you to try. So have a go at these ones. Okay, firstly, write in standard form 25,500. So we want a number between 1 and 10, which is going to be 2.55 here. And then we're timesing 10 a certain number of times. It's going to be 1, 2, 3, 4 times. The second one, a number between 1 and 10, is going to be 7.4 times 10 to a power. It's going to be a negative power, and it's going to be 4 times. So 7.4 divided by 10 4 times makes 0.00074. And write as ordinary numbers 9.8 times 10 to the power of 6. So times 10 once for 98. 2, 3, 4, 5, 6 times. And that's 9.8 million. 1.22 times 10 to the power of negative 3. So we're going to have 0.00, 3 zeros in total, and then 1, 2, 2. So now we're going to look at multiplying and dividing standard form. So when we multiply standard form, we can multiply the numbers and multiply the powers separately. It's like having 3x to the power of 7 times 5x to the power of 4. So if we multiply the numbers, 3 times 5, 3 times 5 is 15. And then we'll do the powers, so 10 to the power of 7 multiplied by 10 to the power of 4. When we multiply, we add the powers, so 10 to the power of 7 times 10 to the power of 4 is 10 to the power of 11. We've got 7 tens times together, times by another 4 tens times together, so in total 11 tens times together. So we've got 15 times 10 to the power of 11. That is correct, but it's not in standard form. Standard form has to be a number between 1 and 10. So 15 is not between 1 and 10, so we can change it into 1.5 times 10. 1.5 times 10 is 15, and then we've got times 10 to the power of 11. And if we've got 10 times 10 to the power of 11, that's actually 10 to the power of 12. So 1.5 times 10 to the power of 12. And dividing standard form, so we could divide the numbers and divide the powers separately, but I'm going to do this one on the calculator. So if we grab a calculator, so there's a standard form button on the calculator, which we need to know about. So we've got 1.15, and then the standard form button is down the bottom, and we just write the power. So 1.15 times 10 to the power of negative 4. Then on the bottom of the fraction, 5.75 times 10 to the power of 6. So it's given us an answer. It's given it in standard form, and it's 2 times 10 to the power of negative 11. Okay, 2 questions for you to try, so have a go at them. The first one, we've got 4.1 times 10 to the power of 6 times 3 times 10 to the power of negative 3. So 4.1 times 3 is 12.3. 10 to the power of 6 times 10 to the power of negative 3. We're going to add the powers, so 6 plus negative 3. 6 minus 3, that's 3. So we've got 12.3 times 10 to the power of 3. That's not in standard form, so I'm going to change it to 1.23 times 10. So 12.3 is 1.23 times 10 to the power of 3. And 10 times 10 to the power of 3, so 10 times 10 times 10 times 10 is 10 to the power of 4. And the last one, I'm going to do it without a calculator. You could do it with a calculator. I've got 1.3 divided by 5.2. That's a quarter, it's 0.25. Ten to the power of minus 3 divided by 10 to the power of minus 6. So I've got minus 3, take away minus 6 in the powers. When we take away a negative, that's the same as adding. So minus 3 plus 6 is 3. So I've got 0.25 times 10 to the power of 3. This isn't in standard form because the number's not between 1 and 10. So I'm going to steal one of the 10s off of 10 to the power of 3. So 0.25 times 10 times 10 squared. 10 times 10 squared is 10 cubed. And 0.25 times 10 will be 2.5. So 2.5 times 10 squared, or 250. So if you type it into the calculator should give you an answer of 250. And then if you were asked to give your answer in standard form, you would have to change that back to 2.5 times 10 squared. Compound interest and depreciation. So here a car was bought for £25,000. In the first year, its value depreciated, so went down by 20%. In the second year and the third year, its value depreciated by 12%. So I think that means in both the second year and the third year, its value depreciated by 12%. So it went down by 12% in the second year and 12% in the third year. So to take off 20% in one calculation, so if I've got 100%, which I start with, and I take off 20%, that means I've got 80% left. So I can take off 20% in one calculation by multiplying by 80%, or even better, as a decimal, 0.8. For the second and third year, I'm taking off 12%. So 100%, take away 12% would be 88%. So to take off 12% in one calculation, I can multiply by 0.88. 88% as a decimal. And I'm going to do this twice. Once for the second year, once for the third year. And I could have written that as 0.88 squared. So I've got 25,000 times 0.8 to take off 20% for the first year, times 0.88 for the second year, and times 0.88 again for the third year. So if we type this into the calculator, we should get our answer. So we've got £15,488. Okay, try this. So this is a question for you to try. So you can pause the video and have a go at it. A bank pays 4.2% compound interest per annum. So every year, the amount of money we've got increases by 4.2%. If you invest £12,000, how much do you have after 5 years? So we're adding on 4.2%. So 100% plus 4.2% is 104.2%. So as a multiplier, as a decimal, that's going to be 1.042. So we want £12,000 times 1.042 for the first year, times that again for the second year, again for the third year, again for the fourth year, and again for the fifth year. So 5 times, and we just type this in the calculator. So £12,000 times 1.042 to the power of 5. So it's money, so we're going to give it our answer to 2 decimal places. So I've got £14,740.76. £14,740.76. and percentage change. So percentage change is a change over the original times 100. So in this example, a car was bought for £12,000. After a year, it was worth £9,840. Work out the percentage change in the value of the car. So by what percentage do you change 12,000 to get to 9,840? So we use the change, so we work out how much it's changed, divide by the original amount, and times 100 to make it a percentage. So the change is the new minus the old. So 9,840 minus the original, which is 12,000, divided by the original, 12,000, times 100 to make it a percentage. So we type this into the calculator, 9,840 minus 12,000 divided by 12,000 times 100, and that's minus 18%. So the percentage change is minus 18%. So if you took 18% off of 12,000, you get 9,840. Okay, question for you to try, so pause the video and give it a go. A shop buys TVs for £280 each. They sell the TVs for £330 each. Work out the percentage profit and give your answer to one decimal place. So percentage profit is the same as percentage change. So it's change over original times 100. So new is 330. Take away the original, 280. Divided by the original times 100. So let's just type it into the calculator. 330 minus 280 over 280 times 100. So to one decimal place, that's 17 point. So it's 5, so it rounds up, 17.9. 17.9%. And finally, we've got reverse percentages. In the example, it says the value of a bike decreased by 22%. The bike is now worth £273. Work out the value of the bike before the value decreased. So this time we are working out the original value of something. So we've decreased by 22%, and if we wanted to do that in one calculation, we could say 100% take away 22% is 78%. So in one calculation, we could take the original amount, which I'll write as x for now, and we can multiply it by 0.78. And that should give us the new price, which is £273. So something times 0.78 is 273. So if we want to find out what x is, what the original is, we can divide both sides by 0.78. So if I divide both sides by 0.78, I'm going to get 273 over 0.78. And we can type this into the calculator. So 273 over 0.78, and that is 350. So the answer will be £350. Okay, a question for you to try to finish up. So pause the video and have a go at it. The price for train ticket increased by 6%. The train ticket now costs £13.25. Work out the price of the train ticket before the increase. So to add on 6%, we will multiply by 1.06. So the original amount times 1.06 is equal to £13.25. To find the original, we divide both sides by 1.06. So type in the calculator, £13.25, 13.25 over 1.06, and that is 25 over 2, or 12.5. And it's money, so it's not 12.5, it's £12.50. Okay, so that was week 2. Standard form, compound interest and depreciation, percentage change, and reverse percentages. You can now give the Maths Grader assessment a go. So the link will be in the description of the YouTube video, or if you're watching on the Maths Genie website, the bottom of the page.